In previous videos, we talked about how containerization helps software run easily, consistently, and independently. But here's a big question. How do you actually put your software in a container? And how do you run that container anywhere you want? To answer that, let's meet the hero behind the scenes. Docker, the container runtime that makes it all happen. What is Docker? What does container runtime even mean? And what are these images and instances people keep mentioning? Let's explain them all with a simple story. This is Sam. Sam works at the docks and cargo handling. He's responsible for packing and loading containers on vessels. He makes sure every shipment is done right for his clients, packed, labeled, and ready to travel across the world. One day, Olivia shows up. She needs to ship a bunch of different packages very fast. So, without missing a beat, Sam grabs a detailed shipping instruction sheet. The instructions that explain what type of container to use, how to pack the items, and where the shipment should go. Following the instructions, Sam carefully packs the container, seals it, and labels it. Then, he stores it in the warehouse, ready for the next trip. When the ship is ready to leave, Sam pulls out the container out of the warehouse and loads it into the vessel. Well, this is really just like the software containerization. And to make it clearer, let's map every step of the scenario to its corresponding technical terms. So, just like Sam, who takes care of packing and preparing shipments, you also need someone like him on your machine or server. That someone is the container runtime. Docker is the tool that does this job, handling all the heavy lifting to build, store, and run your containers. In the next step, Olivia hands Sam a detailed instruction sheet. It tells him exactly what to do, what size container to pick, what items to pack, in what order, and even how to secure everything. So the shipment is always prepared the same way. Now, in the real world, you need to write a Dockerfile. Dockerfile is kind of a blueprint or the instruction sheet. It tells Docker exactly how to package your software, what dependencies to install, and whatever necessary for the container image build phase. In the next step, Sam carefully follows the instruction sheet, step by step, packing Olivia's goods neatly into the container, checking everything twice to make sure everything is on the right discipline. In the real world, you use Docker build command. Docker build uses a Dockerfile as its guide to assemble a container image. This would result in a runnable image, meaning that all of the parts of the application are now bundled and assembled together. Next, when the container is ready, Sam sticks a label on it, a tag or a name that identifies the container identity or its purpose. In the real world, you use Docker tag command. Docker tag helps you manage versions of your image, so you always know which one to pull and run later on, whether it's for testing, production, or a specific feature. After labeling the container, Sam moves it into the warehouse, so it's safely stored and ready for pickup whenever it's needed. In the real world, we use Docker push command. Docker push uploads the created image to the container registry, such as Docker Hub, Amazon ECR, and this registry is like your software warehouse, keeping the image organized, versioned, and accessible. In the next step, when it's time to ship, Sam pulls the container out of the warehouse and loads it onto the vessel. Similarly, in the real world, before running a container, we execute Docker pull to download the correct image from the registry. As the command says for itself, Docker pull pulls the image and making everything prepared for the final run. Once the container is loaded onto the vessel carries it across the ocean, delivering it wherever it needs to go, reliably and on schedule. This last step in the real world is done via Docker run. Docker run spins up a running container instance from the image and brings your application to life. From that moment, your application is active and ready to serve requests, whether it's on your local machine for testing, in a staging environment, or in the cloud for production use. And yeah, that was a simple explanation of how shipping logistics and Docker containerization mirror each other. Just remember, once you've got Docker set up, you have everything you need to package, store, and run your applications consistently wherever you need them. Alright, that was it for this video. Please make sure you subscribe to our YouTube channel, and I see you in the next video.